I'm here to talk to you about why your project turns to pasta, and be that spaghetti, lasagna, doesn't really matter. Projects turn to pasta, and we need to do something about it. But before we get started, let me tell you something about me. My name is Chris Jansen. I'm roughly 31 years old. I'm going on 32 pretty soon, so getting old. I'm a father of two, and for the first time in my speaking history, I've actually got them with me, which makes me kind of nervous, which I don't normally get. I've been programming since I was about 8 years old, so that would be circa 95, and I'm currently a developer for the British company Decent, who I'll, unfortunately for them, and me as well a little bit, be leaving. And I'm starting a new job at Ordina in the Netherlands as their competence lead Drupal. And I've got about 7 years of experience with Drupal 6, 7, and 8. But since you've all got lunch inside your bellies and all the energy is going down there to process that and make sure that you have more energy later on, I'd like to get some of that energy back into your brain to actually hear what I have to say. So let's do a warming up exercise. Could everyone who has an active role in software development stand up, please? And that could be a programmer, user experience designer in general, project managers, everyone who has, an active role in Drupal development, or in software development. Right, so I guess that's about everyone. Don't worry, I'm not going to have you dance or do all kinds of crazy stuff. But now I'd like everyone who identifies himself as as male, to sit down, and everyone who identifies themselves as female to keep standing up. And here's where I see a problem. I mean, we're here, let me just estimate, roughly 100 people. And there's 1, 2, 3, 4, let's barely 10 female people around here. That's a problem. What are we doing wrong, people? I know that, you can sit down, ladies, thank you for standing up. I know that, a lot of women have trouble in our community. Be it from, not feeling safe at conferences, which is why we have, unfortunately must have the beautiful things we call codes of conduct, but also because of the, the general working environment. It's kind of like, a frat boy environment, or not really women friendly. But some of the best developers I know are women. So, maybe it would be a good idea for us all to make our community as welcoming as possible to, anyone, not just developers who like to drink a beer every now and then, and, instead of trying to scare these wonderful people away. But this has got nothing to do with what I am going to talk to you about. It's just something that keeps me up at night every now and then. Right. Projects need good code. If they don't have good code, they turn to shit. Sorry, my French. Excuse my French. But we all start with the best intentions, right? I mean, can I have a raise of hands? Who starts the projects with their best intentions? Who thinks, I'm going to go fast this time? I'm going to go well this time? Everyone starts that way, right? Could I now have a show of hands who has ever been slowed down by bad code? In any form. And now, this is the tough one. And who has been slowed down by bad code that they've written themselves? Right? We've all done it. So, what do we all consider good code? Could I have some examples from the audience? just shout out some properties of good code.
Follow design patterns. Following design patterns.
I couldn't really... Following design patterns, yeah. Yeah, that's a, good code follows design patterns. Any other ideas?
Use parameter definitions, so you know what the parameter is going to be used as.
Parameter definitions, you mean in code blocks above functions so that you can know what...
That's what...
and type hinting and everything, yeah. Keep it simple. KISS. Keep it stupid simple, or keep it simple stupid, depending on who you're talking to. There's a couple more. Good code adheres to coding standards. Doesn't really matter which coding standards, as long as you as a team choose a set of coding standards and adhere to them. It's extensible, it's reusable, and everyone who's been in a computer science class has heard these. It's decoupled. It's not like I change something here and everything breaks over there. And everything has a single purpose. And it's also structured and highly readable. Basically, good code is maintainable and a pleasure to work with. We know this to be true, but why do we fail to write it? Let's find out. So how does this code turn to pasta? I'm going to take a very simplified example of a shopping cart, or something that closely resembles it. And let's say our first requirement by the client is like, we need a list of all purchased items, and we should have a display of their grand total. Well, easy enough, right? You just have a total variable. Can you read this? Yeah, probably can. You look through all the items in the list, you print them out. You increase the total, and you print out the total. Easy peasy, right? But then the client comes back and they're like, wow, this is really cool. But I forgot to mention something. We also have shipping costs. So they should be printed too. And there should be like a subtotal, and the shipping costs should be in the grand total as well. All right, let's change it. Let's add something more. Let's just print out the current total as the subtotal, and then add the shipping costs to it and print it out again. Works so far. Are we all keeping up? Probably. But then, Penny also wants to run various promotions, starting with the fact that, new customers get a 10% discount. Well, okay, we've added that. And then she starts thinking of some more. So we add some more ifs and some more elses, and we put a bunch of code in there. And all of a sudden, things are getting out of hand. This code is growing. It's getting, I've had to strip out some stuff to be able to make sure that it all fits on the screen. And this is where, it isn't necessarily going all places, but it's still going to be harder to read and harder to maintain if we keep going down this road. So we've got to refactor this. And this is something that project managers probably dread, this word, refactoring. How many project managers are here, by the way? Can I have a show of hands? There's one? Good for you. Anyway, so we need to refactor this. It's functioning code. It does what it's supposed to do. There are no bugs. But if we keep developing it this way, things are going to go bad. So what I did, separated out the things that we did in that one chunk of code and made several little functions, to improve the readability. So now in the first section of the code, we do all the calculations we need to do. we get the total amount, the subtotal, we get the shipping costs, and we all, put them together. And then in the second bit, that does one single thing, and that one single thing is going through all these items and printing them. And this is very clear. Whenever I need to change the way items are printed, I just, press, in my case on Apple, I press Command-click. And there we go, I go into the function. My IDE will take me to the function in question, and it will tell me exactly what's going on to print these things. So the printing of items is contained in one thing, the printing of a discount is contained in another. So this code is more self-expressive. But also if you want to change the order, for instance, if you want to say, you know what, we want to print the subtotal after the discounts or whatever, it's just a matter of changing these two lines. You don't have to take a whole chunk of code, take it out, put it somewhere else. Which brings us to clean code. So what do we consider clean code? It's obviously written by someone who cares. And apparently, that's what people like to see, is that it reads like well-written prose. You have these cheap, without being disrespectful, these cheap pocket romans. They read really easily. That's how your code should read as well. And I'm standing on the shoulders of giants here, because many people have said things about this. Michael Fetters, for instance, said that clean code always looked like it was written by someone who cares. And there's obviously nothing you can do to make it better. But also, it's a very difficult name, Bjarne Strup, the inventor of C++. I think I'll call him with this title next time. I like my code to be elegant and efficient. The logic should be straightforward and make it hard for bugs to hide. Clean code does one thing well. And, Ward Cunningham said something about that each routine you read should pretty much end up doing pretty much what you expected it to do. So why should you want to have clean code? If you look at the time you spend reading code compared to the time you spend writing it, who thinks they spend about 25% reading code and 25% writing code? 75% writing code? No one. Who thinks it's about 50-50? Still not? All right, we have one who thinks it's at 50-50. 75-25? That's more like it. Or is it even worse? Sometimes, yeah. So the ratio actually, as research has shown, is about 90% of the time you spend reading code and 10% of the time is writing code. So making code easier to read actually makes it easier to write, because you don't have to think about, what is this doing before you can start thinking about how can I improve this. So how can we do this? Well, the simple thing is just use meaningful names. I mean, in this example, you have two variables, fn and ln. And, well, thanks to a comment, we know their first name and last name. But it could be anything, right? Fn could even be a function name. But it's so simple to change this. You no longer need to comment, and all you have is variables that describe what's in there. The first name and the last name. Or how about this one? Variable C. C could be anything. Is the result of something that, is a dbcon, and it takes two admins and a local host and a 1, 2, 3, 4. You can kind of guess what it's, what it is. But this would be more expressive. Connect to database returns a connection object, and it takes a username, a password, a host, and a port. It's It's a lot easier to read this and to make changes to code that's written like this. Why is this? Well, for instance, it takes a lot of effort mentally, without you really noticing it, to just keep track of all these cryptic names. And all that mental capacity is, well, inaccessible to whatever you're trying to do. One of the things you should do besides naming your variables is also prevent things like magic numbers or strings, the things that just pop up every now and then, where you have like some variable and then a 2 is assigned to it. What's that 2? Could it be, the number of seconds to wait on something, or what is it? Probably better to have, a declaration somewhere of a constant or an enum. Another thing to do is to use consistent return types, and this is something we do very badly in Drupal. We've all seen this, right? Something that returns an array, or null, or it returns a list of objects, or a boolean. Having code that does this forces you to constantly check what you're getting back, and whenever you call that function, you'll see something like if the result isn't false, or if it isn't null. And these checks are everywhere. They pollute your code, they make it harder to read, they make your functions longer. Which brings us to don't return null. I mean, if load pages returns null, and this is pretty much an example of what I just said, you'll see your code littered with if pages not equals null, you do something. It would be a lot better for it to just return an empty array if there are no pages to be loaded. Now you'll always get an array. If it's empty and you loop over it, you just won't do anything within it. And it keeps your code shorter and simple. It's the same thing when you try to do something which should return an object. Let's say a logger. If it returns a null, if no logger was configured, you still have to do a null check. And you'll have to do it wherever you want to use that object. You could always also just return a null logger object, which implements the logger interface, but does nothing. So you have the same, idea. There is nothing configured, so we'll default to something that does nothing, but we don't have to check all the time. Or you could just throw an exception in cases where you actually need something to be returned. And then that exception can just bubble up through the code until it reaches a point where it's caught, or it will break your system straight away. So you know that something went wrong, instead of it silently being handled somewhere by just, not doing anything if there was an invalid return. Which brings us to something which is very controversial. Try not to write comments. Comments are lies waiting to happen. Literally. You write a piece of code. I see this all the time, and then you have all these comments explaining what the code does. We're programmers. We can read code. We know what it does. But then someone comes around and makes a change, but forgets to change it, forgets to adjust the comment. Now the comment is wrong. Then the code in which it was originally planned out for, or written for, is removed altogether. There's another function took care of it. But the comment still is there, because I don't know whether or not I can remove this comment. And before you know it, it's literally telling a lie, and it's making it harder for you to read and understand the code you're reading. However, if you do something for a very specific reason, document the reason. I mean, comments are a powerful tool, but you should only use them when it's necessary. So whenever you feel like, I must write a comment to explain what's going on here, take a step back, because it's probably just your code failing to express its intent. And now we get to the design principles, which were mentioned earlier. These principles were coined by Robert C. Martin, or Uncle Bob. Have any of you ever heard of him? a couple. Look this person up. You know, you have a powerful tool called Google. Google this name. This man has been around for, you know, decades, and he's the one who came up with the solid design principles, and he's very capable of explaining them, you know, himself, and he's literally done it in several different talks, and you know, each of these could be a talk on its own, so I'm not going to dive into them. But research them, because code that adheres to these principles is code that's clean, that's well maintainable. And if you should only, you know, if you don't have much time and you should only, you know, review one of them or research one of them, make it the single responsibility principle. That's, in my opinion, the best principle for improving your coding style, because it inherently brings the other ones with it. Code review. Could I have a show of hand who does this daily? Okay, who does this in general every now and then? You know, it's about half. In my opinion, every developer should have a form of code review in their development process. It's not because you're a bad developer. I mean, you're obviously capable of what you're doing. But code review helps you and your team to glue together, to understand each other, it's a way to look into one another's mind. And it's also a very good way to you know, point out when code is hard to read. Because when I write something, it might make, you know, perfect sense to me. But if my colleague is like, what the f is this doing? Then I've obviously done something wrong. Not necessarily because the code is wrong, but I could improve myself. So these code reviews should contain only constructive criticism, because you're opening yourself and your code and your work up to someone else. So make sure that whenever you criticize someone else's work, you do it in a very constructive way. Don't go finger pointing, but tell them that they did well, but every now and then something might be needed to improve. Because the goal of code review in the end is to learn from one another. And in my experience, introducing code review into a team starts out by slowing you down tremendously, even though that's the opposite what we want to do. But give it a couple weeks, and then everyone knows what other people expect from them, and they start to know how code could be written in a meaningful and a self-expressive way. And then things start to speed up, because then your code will be clean when it enters the code base. And whenever you need to, you know, make a change to it, you don't have all that mental capacity being lost because it's hard to read. And then one of the most important things whenever you're working in a legacy code base that looks like crap is the Boy Scout rule, which basically says, try and leave this world a little better than you found it. And in software development, you can translate that to try and leave your code a little better than you found it. So whenever you open a file and you look at whatever code is in there, and you're like, you know, it's giving me the creeps. You know, we've all had that experience probably. Don't just make your change and get out of there. But take a look at the way, besides making a change, how you can improve that code. Maybe you could rename a variable here and there. Maybe you could, you know, make a big function shorter by extracting some other functions. All these little changes in themselves don't do much, but when you combine them over time, your code base will start getting better, and your mess will become less and less, which will speed up your process in the long run. So basically, any effort, no matter how small, improves your code. And then automated testing. Who does this? How about I could get some examples from you guys or girls about what you think is the best reason for automated testing. What does it help you with?
Preventing bugs.
Preventing bugs. Yeah. Yeah.
Confidence in refactoring.
Could you repeat that?
It gives you the confidence to change code.
Yeah, the Boy Scout rule pretty much needs this to be able to be very effective, because you don't have to be afraid that something breaks after you touch it.
Validate your exceptions are handled correctly.
Validate your exceptions are handled correctly, yeah. Just the other day I made a change to, a very simple change to a very simple bit of code, but it turned out that it cost, a 500. Well, I didn't get it because it was somewhere where I didn't expect it. But my test written for a totally different feature did get it. Which meant that my client didn't get it. And that keeps them confident in our abilities. Which brings us to test-driven development. This is a practice I personally do all the time. The first thing I do is I write my test before I write any code. And once again, this is a topic that I could, talk for hours about, and could have, a talk on its own. So please research this and have a look into it. But by writing your tests first, by thinking about how to make your code testable, A, your code is more testable, easier testable, but B, it improves the design. Because if you have to mock up everything before you're able to write that class you want to write, well, that's not something you like to do. And when you do test-driven development, you'll make sure that you don't ever get into a situation where you have to do that. So you'll have code that has less dependencies, and in turn is, better and easier to maintain. But it also discourages bad practices, like the use of global functions. It's just stuff like that makes code hard to debug, and test-driven development prevents it. So there are many automated tests, of course, and I think the easiest ones, or the top-level ones, are acceptance tests. You'll find these in various varieties. You'll find them in the form of behead tests, or in the case of Drupal, in the browser test-based class. Ideally, these acceptance tests are an exact mirror of your acceptance criteria. And it might, if you use behead, for instance, you can actually write these tests with your client whilst you're talking to them. And these tests, especially if you write them up front, keep you focused. They keep you focused on the minimal viable product. Because all you're trying to do is implement as much code as you need to implement to make these tests pass. And once they do, you've proven that you've met your acceptance criteria, because they're a one-to-one match. But you got to be careful about acceptance tests, because they're often tested through the UI, and well, we all know UIs tend to change. We all have had this client who was like, yeah, this looks really good in orange. And then a week later they'll be like, but now I want it blue. That brings about changes in your UI and might actually break those tests, not necessarily because the functionality was broken, but just because the means of testing had been broken. So you have to be careful about how you construct them. Then there are integration tests. They're a level deeper, where you take subsystems and you hook them up together. These, usually don't touch the UI. They're just code talking to code. But they may need a database, which still makes them pretty slow. Kernel test base is a good example in Drupal. They, all the integration tests are based off of that. And then there are unit tests, which test the smallest chunks of code in your project. And these should be blazingly fast, because as a developer, especially when you're doing test-driven development, you want to be able to press that button like every other minute for them to run, and run quickly, so you can quickly know that something broke. They obviously don't touch the UI and they don't touch the database, because those are slow and you don't want anything that's slow in there. Unit test base is a very good example for Drupal. And then there's time management. And, this is probably something that the project manager in the room is going to love for us to talk about. I mean, we're all familiar with estimating, I think. Anyone not familiar with it? Pretty much everyone needs to estimate before they can start with something. And to us, an estimate, it's just an estimate, you know. I think it might take 4 hours. But it should ideally consist out of 3 numbers, you know. If everything goes okay, if I get my daughter out of bed in the morning and nothing, nothing gets in my way, I don't get disturbed, yeah, I think I can do this in 3 hours. If I have, a meeting every now and then, maybe it'll take me 4 or 5 hours because I've got to do some context switching. But man, if every day of the week is like stuck in traffic and, the worst day of my life, worst case scenario, it might actually take me 20 hours to do this. That should be the ultimate estimate you can do, like those 3 numbers. For an issue on itself, it doesn't say much, but if you have all issues or all things you need to do estimated like that, you can actually start doing some statistical analysis on it. And that's something project managers love to do because it's their job to make sure that things get delivered on time. And they would be able to actually calculate roughly when it will be done. Because in the end, managers and clients see estimates as a promise, even though it isn't one. And we should, be very careful not to promise them things we can't achieve. Which brings us to an example. So let's say you're working on project A, and you're typing away happily, and all of a sudden Alice comes by, because she's the project manager for project B, and she needs a new feature. So she'll start talking straight away, and you're like, let me finish what I'm doing, let me finish my chain of thoughts, let me store this mental space somewhere so I don't get lost. That's not an option. She needs an answer, and she needs it straight away, because the client is on the phone. When can it be done? So you ask, what's needed, she gives an explanation, and you'll be like, okay, yeah, I think I can do that in about 4 days, maybe 5. So what you say is 3 weeks. Because, I've got other things to do, right? I was working on project A, that needs finishing. I know there's going to be, a support call coming down the line. So 3 weeks, I can have it done in 3 weeks. So week 1, as expected, you finish what you were working on. And week 2, start on Monday, start fresh, actually start on the feature. But after about 25 minutes, a critical system hangs. And there's your support system, your support call, and it's going to take you the rest of the week to finish that up and to make it all go back to normal. So week 3 comes along. And you actually have to get started on this because, 4 or 5 days, that's, about a week. So you get to work. And then on Tuesday you think, shit, this was a bit harder than I anticipated because I didn't have all the facts, and now I do. And it's actually going to take me more in the direction of 10 days to get this done. So we're not going to make it. Let's explore our options. This is one I've seen very often. Developers then are like, shit, I promised 3 weeks. I promised to meet the deadline, so I'm gonna meet the deadline, so I'm gonna rush to get things done. And when Alice comes by, I'll tell her, everything will be fine, Alice. End of this week, you'll have your feature. But, in the end, you'll deliver poorly tested work. It breaks stuff everywhere, or you don't deliver at all. And pretty much faith in your ability as a developer has been lost. I would lose faith in myself if I'd done it that way. So there's option B. You still rush to try and get things done. But when Alice asks, you tell her, I'm not going to make it, Alice, sorry. Then she tells you, can you at least try? Can you at least try to make it by Friday? Well, you're like, I don't know, maybe if I put in some overtime. Come on, try, give it your best. And you're like, all right, I'll try. But you won't deliver. And you won't deliver. And once again, faith in your abilities is lost. Or option C. On Tuesday, when you figure out that you're not going to make it, drop what you're doing. Stand up, go to Alice, tell her, Alice, sorry, it's Tuesday. I've got about 3 days left, but I've got 7 days of work left. So please, can we talk about this? You explain the options because you've thought of those. You tell her, these bits are easy, these bits are hard. And you let her prioritize. You let her think about the things she needs most, and let her drop things she can't or she doesn't need as much straight away. And then you implement only those things you can implement and those things that she prioritized as being important. She might not get everything, but at least it's got quality, and she's still viewing you as a professional because you've actually, fessed up and told her. Slow and steady wins the race, people. Rushing never helps you out. If you're in a hurry, stay calm. I mean, if you see a disaster somewhere in the world and the news reports about it, and who do you see usually surviving things like that? It's not the people who ran around like headless chickens. It's the people who stayed calm, who anticipated the situation, who looked at it and are like, this is the best way forward. So whatever you do normally in a normal situation, stick to that, or even stick to it even stronger once you get in a stressful situation. Because whether it's test-driven development, pair programming, code review, or whatever works for you normally, it's going to work for you in stressful situations. So don't allow yourself to be rushed. Like I said, don't allow yourself to be rushed. Keep repeating this to yourself every time you feel stressed. And for project managers, which we only have one of here, unfortunately, don't rush your people. It's hard enough as it is. And then there's saying no. No, truly, managers aren't out there to make your life miserable. That's not their job. That's not what they were hired for. It's their job to worry about deadlines. It's their job to worry about keeping the client happy, about getting the project there on time. And it's their job to mitigate the risks surrounding it. It's your job to deliver on whatever is promised, and if you've done your job correctly, you've only promised things you can keep. But managers do need honest answers to do their jobs, even if that answer is no. So every now and then you'll run into a situation where they want you to build something which, would probably take dozens of hours to implement, where you know that a simpler solution should be possible. You could just say, yes, sure, I'll do it. Or you could say, no, I won't, because it's not effective for us, it's not effective for a client. And that will actually help you as a team, because your manager is part of your team, whether you like it or not. And it will help you as a team grow, and it will help you as a team become better at what you're doing, but it will also keep a happy client. Because in the end, the client wants to have something that works for them, instead of just giving you money for something that doesn't work. So in closing, be and act like a professional. Take responsibility for your code. And only make commitments you can actually fulfill. Don't take shortcuts, don't be rushed. Help each other grow as a team, because only teams get it done. And be honest. Tell someone if you've messed up. That's all right, we're humans. If you've made that bad code at some point, just tell your client, shit, that piece of code is shit. I need to refactor it, you need to fix it. And we'll figure out how we'll do it financially, but this needs to be done for me to be able to continue helping you. And communicate. People always have this impression that developers are people who like to sit in a dark attic with a little sliver of light coming through. That's not developers, that's nine-gaggers, We actually should be capable of communicating whatever we need and whatever the client needs and whatever the project manager needs. We should be able to talk about that, and we should be able to, how do I say that correctly? We should be able to influence the way projects run, and the only way to do that is by communicating. Thank you. Are there any questions? No questions at all?
Yes.
Yes.
I want to ask about the last point you're talking about, and then going to the ego of the developer. Because that's, and not maybe only an ego, but this is just, he really thinks that he can make it within this time. And he also wants to show everybody else in his company and his product manager or his bosses that he's also capable of doing it at such a certain time. How can you actually, in the estimation phase, get this out of the developer and just a little bit, do you have any tricks of how to, because I think the more professional, the more senior developer is, the more honest he is about it. But the juniors maybe tend to be more, egoistic, or
I think they're more naive. So what you're asking is, how can you make junior developers give honest and accurate estimates?
Do you have any good tips for that, or how that can be done?
Well, hold them accountable. Whenever they say, I can have this done in 2 hours, hold them accountable. Make sure that whatever code they write goes through code review and is reviewed not by a junior but by a senior developer. And then they'll start to figure out why senior developers estimate for higher numbers of time. Because their code will go through, they'll find stuff that could be improved, and it will go back and forth, and those 2 hours will turn out to be 10 hours, because of all the communication around it. And then say, you said 2 hours, it's 10 hours. No worries, you're not going to be fired or anything, but think about what went wrong. Make them think about what went wrong. And sure enough, in a matter of months, they'll get their estimates correct, just from it being visible.
And then one more, sorry?
Sure.
Then comes the next part about Drupal 8 having configuration management, Drupal 7 having features, not features, having when you're a developer, you're maybe not 100% in that project, especially when you're doing support. Of course, if it's Drupal 8 or Drupal 7, and you maybe have some idea. But would you just say that a programmer should just only estimate the time that it takes for him to do it without having the whole deployment around it? Or would you, is that a responsibility of the project project manager or those who are looking at setting up estimation? What's the problem?
So your question is, where does the responsibility of the programmer end in terms of estimation? Should they estimate their bit of the work, or should they estimate the entire deployment period? It depends, as with everything in software development. If you have a situation where whatever's developed goes through a pipeline and is deployed straight away, continuous integration, then it should probably just be, his own work. How long do I need to fix this? And then, being confident that whatever issues may arise will arise during the deployment process. However, in many cases, there's always going to be some project management stuff around it. Maybe things only get deployed once a week or once a month, or, it depends. But in those cases, I still think that the developer should only be responsible for his part of what he's doing. So they should only estimate whatever they have influence on. Because that also, all the other stuff, the deployment, that's usually a fixed amount of time. So if the developer says, I'm going to need 3 hours to implement this, and then everyone knows that they have to add half an hour or an hour of deployment time on top of that for it to be an accurate estimate. Does that answer your question?
Yeah, I think it is just a big discussion.
Yeah, it's difficult. Maybe we can talk about this later at the end of the talk. Any other questions?
And I have one more. So BHAT testing.
Yeah.
So BHAT testing, you talked about it before, we do it too. Who does it? The programmer himself or the project manager? Like defining the test cases? Or do they do it together?
Who is ultimately responsible for the quality of whatever you deploy? That's the person who should write the acceptance test, because they're the ones who actually accept the thing you're deploying. So if that's the client who has final say, then the client should write them, and if they don't know how to write them, then you take someone who does know and put them next to the client and do it together. At Decent, where I currently work, we actually have a user experience expert on every project, and it's their responsibility, because they're not only responsible for user experience, but they're also responsible for accepting the work. So they write the BHAT tests, and they won't function straight away. It's always going to be the developer who actually has to do some little tweaks and things, but in general, the acceptance criteria are written down by them in Gherkin, pretty much ready for BHAT to work.
In my experience, when you have smaller projects, which have smaller budgets, the project manager or project owner, they will set a limit on what hours you can spend on a certain type of thing. And you're stuck.
Yeah, it's the good old ain't nobody got time for that. Yeah. They shouldn't care, they shouldn't know. And a very simple example about that is, if you're going into the hospital for open heart surgery, right? Are you going to tell that surgeon that he shouldn't wash his hands because it's going to take too long? If you have your accountancy done by an accountant, are you going to tell him, you know what, skip the double entry bookkeeping, that's taking too long, I'm paying you by the hour? Those are practices that are there to make sure that whatever job you're doing is done right. They're guarantees, insurance. We don't have sets, things like that in our, developer community, in our profession yet, but we should. And in my opinion, automated testing should be one of them, and it should be just one of the practices, like washing the hands for a surgeon, like double entry bookkeeping. So they shouldn't care about it. Whenever I write code with tests. And if they don't want it like that, they can go somewhere else. Any other questions?
I want to ask one question about the code. So imagine you have a class function and you see that it's a really dirty function. So you start to work on it. At some point you clean up the names, you clean up, you moved some code around and it looks much better, but you still feel the smell, but you don't know what to do next. What is your strategy to deal with such kind of situations?
So what you're asking is, let's say you have an ugly function, something that smells from every direction you look at it, right? And you go about cleaning it. You rename something here, you move some code out into a separate function, you do all the tricks you have up your sleeve to improve that function, and then in the end, it's still smelly. What to do about it? You know, as with everything software development, also this depends, but usually whatever you're trying to do has been done before. There are countless presentations on YouTube to be found about refactoring code. And if you just sit down for, a weekend and go through those, just look at the things they have to say, I'm sure the solution will come along. Because especially if you take a look at things that are done in a different language than the language you're used to programming in. So if you're trying to refactor in PHP, have a look at someone who does refactoring in Java. Or have a look at someone who's doing refactoring in, maybe even a functional language like Clojure. Because they will use patterns you're not familiar with, and they have a very high chance of actually teaching you something new. And sure enough, you'll have more tricks up your sleeve. I don't know how much time is going to be needed for the announcement in a bit, because we've got about 7 minutes left, I think. Any other questions in the meantime? No? Well, thank you all very much for coming. If you have any feedback on my talk, please, leave it in joined in, so that I can improve myself. And hope to see you next time.